Hi there. In this series of videos, we're going to talk about some additional considerations in hypothesis testing, and we'll get a lot more practice while we're doing that. And in this video, I want to talk about decision errors. So I'm not talking about where we're going through the process and we make a mistake, we do something wrong. That can happen for sure, but that's not what I'm talking about here. What I'm talking about is we go through the whole process correctly, but we actually conclude something that is the opposite of what we should have concluded, okay? So this can happen, right? Because everything is based on the chance, the probability. So this definitely can happen, and we're not going to know it's happening. So maybe we'll find out later on, but we're not going to know that it's happening initially. Okay, so let me talk about the two different types of error. There's a type 1 and a type 2. So a type 1 error is when we conclude for the alternate when it's not actually true in real life, okay? The probability of doing this in the long run is alpha, which we've seen that's the same as our significance level. I'll talk more about that in a bit. This is known as a false positive. So you're probably familiar with, say, COVID home tests where you might get a false positive or a false negative. In that case, usually it's a false negative, and that's why we need to keep testing. You keep testing every day because that reduces or increases the chance you'll catch it, right? Okay, so then a type 2, I'll come back to this part here. So a type 2 error is when we conclude for the null when it's not actually true, and that's called a false negative. Okay, so a false negative on a COVID test is a type 2 error. Okay, so we'll come back to that, but I want to show you this diagram because this is really helpful for me, so I hope it's helpful for you to visualize all the different possibilities here. So it's called a tree diagram because there's two branches, and then each of the branches has more branches. So I initially have two possibilities, and this is what's actually true in real life, right? I'll put in real life, or what's actually true. There's two possibilities, so there's two branches. The top one is the null is actually true, okay? And the bottom one is the alternate is actually true. Okay, so then in each case, I'll do the top branch first. There's two possible decisions we could make from our test, right? We could either fail to reject the null or reject the null. If the null is true and on the top branch we fail to reject the null, then we've made the correct conclusion. We've decided in favor of the null, then we've made a correct conclusion. Our test has worked very well. Okay, but if the null is true and we reject it on the second branch here, that's a type 1 error. That's a false positive. Okay. Similarly, I'm going to go down to the second branch here if the alternate is true, okay, and that has two branches on it. If the alternate is true and we reject the null, we're siding in favor of the alternate. So I actually have this on the fourth branch. Then we've made the correct conclusion for the alternate. Okay, so also, again, we're very good. Done a great job. But if the alternate is true and we fail to reject the null, so that means we're siding in terms of the null here, but the alternate is actually true, we've made a type 2 error, and that's our false negative. Okay, so whichever works better for you. If the tree diagram works better or the written out in words works better, sometimes you'll see a grid as well, a 2x2 grid. That's another way. It's probably in our book. It's another way to look at it as well. Okay, so let's do an example, and that might also help as well. So here's our example. A new drug is being tested to see if it has a more significant effect than the current one. Okay, so we've got a new drug. Does it have a more significant effect than the current one? Okay, so let's write out the hypotheses in words. So we're not given any sample statistics or parameters here. So it could be a mean or a proportion, depending on what was being measured. And it also could be one parameter or two parameters, depending on how it was set up. So this applies to all tests. Okay, so our null is usually, remember, there's no effect, right? Or status quo. So we would say the new drug is not more effective than the current one. The new drug, I'm going to say, is no more effective than the current drug. Usually if it's the same, then we side in favor of the null because something has to be better to be generally to be accepted. So the alternate is the new drug is. More effective. Than the current drug. Okay, and then this is where you can also use the diagram if it's helpful for you. I'm going to go ahead and write this on the diagram and say that if the null is actually true, then I'm going to say the current drug is better. That's a little bit, could be the same, but I'm just trying to make it more clear for this example for understanding's sake. So if the current drug is better, then the null is true, and if the new drug is better, that's the alternate. Okay, so if the new drug is actually better, then the alternate is actually true. Okay, so then what is a type 1 error in this case, and what are the consequences? We want to understand what could happen if we make a type 1 error, okay? So type 1 error is when we conclude for the alternate, but it's actually not true, okay? So if we say the new drug is better, but it's not, we conclude the new drug is better, but it's not. And that's a false positive, right? The positive meaning the alternate. So if we conclude the new drug is better, but it's not, that's a type 1 error. And I'm going to go ahead and write the type 2 at the same time. That would be the reverse. We conclude the old drug is better. The current drug is better. But it's not. Okay? Okay, so what are the consequences of each one? So if we conclude the new drug is better, but it's not, we're giving people a new drug that's not really effective, right? So giving a new drug that's not effective. Or I could say not more effective. And then if we conclude that the current drug is better, but it's not, we would be not giving a new drug that is more effective. It's a real brain bender. So sometimes if you get one, then go off of that one, okay? So type 1 error, we conclude the new drug is better. That's a false positive. Type 2 error, we conclude the new drug isn't better, but that's a false negative, okay? So which is better or which is worse? I don't know. Either giving a drug that's not more effective or not giving a drug that is more effective. Which is worse? It kind of depends on the specifics of the situation, right? Is this a drug that cures cancer, or is this a drug for a stomach ache? What's the severity? What are the consequences? Is it life or death? So I think it's going to depend on each individual case. So let me go back up to the top, and I also have a note down at the bottom here. Back up here, I skipped this part, so let me put some arrows here. Depending on which is more dangerous or costly in a situation. So if making a type 1 error is more dangerous or costly, we can make alpha smaller And then that reduces the chance we reject the null, right? So this is over the long run. Let's say it was 5% chance. If we're under 5%, we reject the null. So in the long run, we say there's a 5% chance of rejecting the null. So we could make that smaller. If we make it down to 0.025 or 0.01, we have less chance of rejecting the null and less chance of making a type 1 error. But then we have to balance that with the type 2 error, right? So if making a type 2 error is more dangerous or costly, we could choose a higher significance level. And then we would be more cautious about failing to reject the null, okay? So there's other things as well that go beyond the scope of this class. There's more about power, and that has to do with sample size, so the power of a test. So if you'd like to know more, take another stats class, and there's a lot more fun stuff to do. And then one more note at the bottom about all this, because these errors can and do occur, right? But we don't know. We might know later on, like if we give a new drug that's not more effective, we'll probably figure that out in a while. If we don't give a new drug, if we put it on the shelf and don't give it, maybe later someone will say, hey, we should really study that again, or something changes, they bring it out. But also, we could just do more testing, right? So since these errors can occur, the replication of studies is really important. And you'll see this, you talk about repeatability and replication. This is happening all the time. So it's a really good practice to make sure a study is conducted in a way that it's transparent and reproducible by other researchers. So when you're outlining, you design your study and you're writing about it, you're writing about your results, you want to outline everything, follow the best practices and outline everything as well as possible, make it very clear so that when someone is trying to, do the study again, they can replicate it and hopefully verify your results. Okay, well, that is a lot about decision errors, and I'll see you in the next video.